Okay, so picture this. A supereruption at Yellowstone. If that happened, Denver would be buried under feet of ash. Not slowly, like over weeks. Just gone. A major American city, 500 miles from the blast, totally unlivable. And this isn't some crazy prediction or a made-up worst-case scenario. This is what the United States Geological Survey, the USGS, found with their computer models. They ran a simulation of what would happen if Yellowstone blew its top like it has before. The model looked at an eruption that ejected enough pulverized rock to fill 330 cubic kilometers. The scientists watched the ash cloud spread, but it didn't do what they expected. It didn't just drift east with the wind. It actually fought back. The cloud generated its own wind, strong enough to overpower the jet stream, and pushed a thick blanket of ash almost 1,000 miles upwind, straight into cities that thought they were safe. And here's the kicker nobody really wants to talk about. The ground at Yellowstone isn't exactly quiet. Just a few weeks ago, on June 13th, 2026, a part of the park just exploded without any warning. A new geyser was born. And honestly, the official alert level doesn't mean much when the Earth decides to just totally change the rules. Here's a number to remember. 1 meter. That's about 3 feet. According to the official USGS models, that's how much ash would bury the northern Rocky Mountains, which includes Denver. 3 feet of ash falling from the sky. And it has happened before. Dr. Harley Benz, a scientist at the USGS National Earthquake Information Center, has studied these past supereruptions. He puts it even more simply. In Denver, 500 miles away from Yellowstone, he said, we've seen 2 to 3 feet of ash in past supereruptions. To really get what that means, you need to understand what volcanic ash actually is. It's not like soot from a fire. It's not just harmless dust you can sweep away. That's a comforting but totally wrong idea. Volcanic ash is basically pulverized rock, minerals, and tiny pieces of volcanic glass. It's hard, it's super abrasive, and it doesn't dissolve in water. When it gets wet, it turns into this heavy, corrosive sludge, almost like wet cement. Just a few millimeters of this stuff can shut down an airport, short out power grids, and mess up your lungs so bad you could die. Denver wouldn't get a few millimeters. It would get meters. A meter of ash weighs about 2,000 pounds per square yard. Most residential roofs in the U.S. are built to hold about 20 pounds per square foot, maybe 40 if they're designed for heavy snow. A meter of dry ash is over 160 pounds per square foot. If it gets wet, it's double that. The math is brutal. Every single flat-roofed building in the Denver area would just collapse. Think warehouses, big box stores, schools, hospitals, all gone. Most homes would follow. The sheer weight of the ash would pretty much bring the city to its knees before anyone could even start cleaning up. The problem isn't just with buildings, it's the whole system. The moment that ash starts falling, our modern world just stops. The power grid would be the first to go. Ash piling up on transformers and insulators, especially with even a little moisture, creates an electrical path. That leads to a flashover, a huge short circuit that just destroys the equipment. The grid wouldn't just go down. It would be physically ripped apart, piece by piece, across thousands of square miles all at once. No power, no lights, no fridges, no way to communicate. Then the water systems fail. Water treatment plants aren't set up to filter pulverized glass out of the water. The South Platte River, which Denver relies on, would become a river of abrasive sludge. The pumps taking water in would be destroyed. The filters would be clogged beyond fixing. The city would lose its water supply. Not just a shortage, not just a boil water notice, a complete stop. Every tap in every home would go dry. And a city of millions without power or water isn't really a city anymore. It's a death trap. And here's the really scary part. You can't escape it. The same ash that collapses buildings and poisons the water also stops every vehicle cold. Modern cars need air filters to protect their engines. Those filters would clog with fine, glassy powder in minutes. Then the abrasive particles would get sucked into the engine, scratching up the cylinders, destroying the pistons, and permanently seizing the engine. Every car, every truck, every emergency vehicle. Totally useless. The roads would be impassable anyway. buried under feet of stuff that feels like a mix of sand and snow. The runways at Denver International Airport would be buried. No traction at all. Every plane on the ground would be stuck there permanently, their jet engines ruined by the same glassy dust. There would be no evacuation, no National Guard convoys showing up with help, no C-130s landing with food and water, just silence. A modern American city of 700,000 people with a metro area of almost 3 million, cut off from the world and buried under rock that fell from the sky, 500 miles from the volcano that caused it. This whole scenario isn't some made-up story. It's the direct result of a sophisticated computer model called ASH 3D, built by a team of USC's geologists led by Dr. Larry G. Maston at the Cascades Volcano Observatory, and they built it to figure out a really puzzling mystery. For decades, geologists studying old volcanic deposits were confused. They kept finding thick layers of Yellowstone ash in places where it shouldn't be, like California or the Pacific Northwest. Those places are upwind from the volcano if you think about the usual westerly winds that blow across North America. The jet stream moves west to east, so the ash should have all gone east, covering the Midwest and the East Coast. But the physical evidence, preserved for 640,000 years, told a completely different story. Then, on August 27, 2014, the USGs published the answer. The ASH 3D model simulated a month-long supereruption, just like Yellowstone's past events. What the model showed was amazing. In a massive eruption, the column of ash and gas doesn't just go up into the atmosphere and drift away. It's just too big, too powerful. It goes up and then spreads out in all directions, forming this giant umbrella cloud that can be hundreds of miles wide. This expanding umbrella is so massive and forceful that it actually creates its own weather system. It makes its own wind. Dr. Maston explained it simply. In essence, the eruption makes its own winds that can overcome the prevailing westerlies. Think about that. The eruption makes its own winds. The outward expansion of this umbrella cloud is so strong that it shoves millions of tons of ash against the powerful jet stream and winds. For hundreds of miles in every direction, the ash doesn't just follow the weather. It is the weather. From space, it wouldn't look like ash spreading east. It would look like a giant bullseye, centered on the park, dropping dense fallout in a full circle before the weaker, outer edges of the cloud are finally caught by global winds. That's why geologists found ancient ash in California. That's why the models show meters of ash falling on Idaho and Montana. And that's why Denver, sitting 500 miles to the southeast, is right in the fallout zone. The city's location relative to the jet stream is irrelevant. It's a nice little fact, but it won't protect anyone. The ASH 3D simulation, which volcanologist Dr. Alexa R. Van Eaton also worked on, predicted fallout reaching all of North America. Cities on the coasts, New York, Miami, Los Angeles, would get a dusting of 1 to 3 millimeters, enough to cause chaos. But the northern Rocky Mountains are in the bullseye. The model's official prediction for that area, which includes Denver, is decimeters to meters of ash. Plural, this isn't just some theory. The ground under Yellowstone National Park is like a crime scene, preserving proof of past events that were way bigger than anything we've ever seen. The park sits inside this huge depression in the earth, the Yellowstone caldera. That caldera is the scar left by 3 incredibly violent supereruptions. The most recent one was the Lava Creek Tuff eruption, about 640,000 years ago. That's what created the caldera we see today. Before that was the Mesa Falls Tuff eruption, around 1.3 million years ago. But the biggest one, the real monster, was the Huckleberry Ridge Tuff eruption, about 2.1 million years ago. The sheer scale of that single event is almost impossible to imagine. It ejected an estimated 585 cubic miles of rock and ash. That's almost 6,000 times bigger than the 1980 eruption of Mount St. Helens. Mount St. Helens killed 57 people and sent ash around the world. The Huckleberry Ridge event was 6,000 times bigger. It was an extinction-level event that changed the climate of the entire planet. Ash from that one eruption has been found as far away as Louisiana and California, buried in the ground over time. So the material that would bury Denver isn't just a possibility. It's a historical fact. The volcano has done it before. The only real question is when it will do it again. And here's how all that ancient history connects to right now. The ground at Yellowstone is moving. It's breathing. And recently, it's been throwing temper tantrums. On June 13th, 2026, at 5:09 in the morning, a sudden hydrothermal explosion happened in Biscuit Basin, one of the park's many active geothermal spots. This wasn't a gentle burp. An area about 100 feet north of Black Diamond Pool just violently ruptured. The blast threw rocks dozens of feet into the air. It shot a plume of boiling muddy water right into the Firehole River, and it ripped open a brand new 60-foot-long crack in the ground. Park officials immediately closed the whole basin to visitors. The ground was unstable and just unpredictable. This wasn't a one-off thing. It was just a continuation of activity that had been building up. Almost exactly 2 years earlier, on July 23, 2024, another big hydrothermal explosion at that same spot, Black Diamond Pool, destroyed the public boardwalk. The Earth was giving us warnings. But what happened in June 2026 was an acceleration. Over the next few days, from June 14th to the 16th, the ground around the new explosion vent collapsed, forming a brand new, round, boiling pool. Then, on June 18th, and again on June 23rd, that new pool started acting like a geyser, shooting columns of boiling water 20 to 30 feet into the air. A new geyser, born in a violent explosion in just a few days. That's not normal, even for Yellowstone. This tells us that dynamic, shallow processes are changing fast, water flashing to steam with explosive force just under the surface. It's a reminder that the park isn't a museum. It's a live, active volcanic system with this incredible network of heat and pressure. The surface is just a thin, fragile lid on top of that system. And sometimes, the lid just breaks. So, is this it? Is this the beginning? Is this new geyser in Biscuit Basin the start of the eruption that buries Denver? The people who watch this volcano literally every second of every day say no. And to understand why, you have to know how they actually measure the threat. In May of 2026, the Yellowstone Volcano Observatory, or WEVO, celebrated its 25th birthday. It started in 2001 as a group of federal and state agencies, including the USGS, the National Park Service, and the University of Utah seismograph stations. Their whole job is to keep an eye on the caldera's pulse. And they're really, really good at it. The current scientist in charge is Dr. Michael Poland, a research geophysicist who specializes in exactly this kind of monitoring. On July 1st, 2026, Dr. Poland's team put out the official monthly update for Yellowstone. That update included all the data about those dramatic explosions in Biscuit Basin, but it also had two other really important pieces of information. First, the seismic data. In June 2026, the month of the explosions, the WIVO network detected 118 small earthquakes. The biggest one was a magnitude 2.4 on June 7th. That's not a sign of impending doom. That's a normal month for Yellowstone. It often sees hundreds or even thousands of small quakes. It's just the constant background hum of an active system. A major eruption would be preceded by thousands of much larger earthquakes, getting stronger and shallower as magma pushed its way to the surface. That's just not happening. Second, the ground deformation data. Using GPS, satellite radar, and sensitive tiltmeters, the IVO watches the caldera floor rise and fall like a slowly breathing chest. This movement tells us directly about magma moving deep down. An impending eruption would cause rapid, dramatic uplift of the ground, measured in feet, not inches. According to the July 1st update, there hasn't been any significant ground deformation at Yellowstone since January 2026. The caldera is stable. Because of these things, no intense earthquake swarms and no ground deformation, the official volcano alert level for Yellowstone stays at normal. The aviation color code is green. The scientists, the people with all the data, the ones who would be the first to raise the alarm, are telling us that even with all the spectacular and dangerous chaos at the surface, the deep magmatic system is calm. The hydrothermal explosions are just that, hydrothermal. Superheated water, not rising magma. Dr. Jacob B. Lowenstern, who used to be the scientist in charge of YEVO, has spent his career making sure people understand this difference. The surface can be wild while the deep volcano is asleep. This brings us to the most common myth about Yellowstone, that it's overdue for an eruption. Volcanoes don't work on a schedule. The time between the last 3 supereruptions was 800,000 years, then 660,000 years. There's no neat pattern. Saying it's overdue is great for clickbait, but it's not science. The scientific consensus is that the huge magma chamber under Yellowstone is mostly solid, kind of a crystallized mush, with nowhere near enough liquid magma to fuel a supereruption anytime soon. For an eruption that big to happen, a massive new injection of magma from the Earth's mantle would be necessary. The instruments would pick that up. They'd see the ground swell, the earthquake spike, the chemistry of the gases change. They're not seeing it. Not now anyway, but that doesn't mean Denver is completely safe forever. It just means it's safe today. The ASH 3D model wasn't fictional. It was a serious scientific simulation based on physics and what we know from past eruptions. It's a blueprint, a detailed, documented forecast of what happens when the calm eventually breaks. The model isn't wrong, it's just waiting. The fact that the alert level is green today is reassuring, but it doesn't change anything about what happens the day it turns orange, and then red. Living in Denver today is kind of like living in a nice house in a floodplain. While the experts downriver tell you the dam is holding strong, you trust them. They have the data. They have the instruments. The dam is solid, but you also know that detailed flood maps exist. Maps that show your street, your home, your kid's school totally underwater if that dam ever failed. You live with these two conflicting ideas, the comforting calm of now and the documented catastrophic potential of the future. Those explosions in Biscuit Basin in June of 2026 are a stark reminder of which truth can show up faster. Nobody predicted that exact spot would rupture that exact morning. The ground gave no specific immediate warning. It just happened. Now, imagine that kind of uncertainty applied to the entire magmatic system over geological time. The scientists are confident it's not happening now. They are confident it's not happening next year. They are not and can't be confident that it won't happen in our lifetimes or our children's. Denver just keeps going. People drive to work, build new homes, plan for the future. All under a sky that looks perfectly safe. They live their lives about 500 miles from a geological feature that has, at least 3 times, buried their exact location under so much pulverized glass it would have collapsed every structure they now inhabit. They live with this massive threat hanging over them, but it's so big it's almost impossible to actually comprehend. The models have been run. The ash maps have been drawn. They're sitting on a USGS server, a published, documented blueprint for the day the alert level isn't green anymore, for the day the earthquakes aren't minor, for the day the ground actually starts to swell significantly. The science is done. The warning has been given.